dear learners, welcome to today's session. Today we'll be discussing on the role of technology in agriculture. As we all know that agriculture has always been the backbone of human civilization. From the hunter-gatherer society to the highly mechanized farms of today, agriculture has changed significantly over time. And this evolution is deeply tangled with technological advancement. Therefore, in this session, we will be discussing the evolution of agriculture, exploring how it has progressed from agriculture 1.0 to agriculture 4.0. We will explore into why technology has become indispensable in modern agriculture, and also discuss the specific roles that a technology plays in transforming the agricultural sector. And by the end of this discussion, you will have a clear understanding of how technology is shaping the future of farming, how it addresses challenges and creating opportunities for sustainable and efficient agricultural ecosystem. So first, let us discuss the evolution of agriculture. As I have already mentioned, the agriculture has evolved to various era, that is from agriculture 1.0 to agriculture 4.0. So what is agriculture 1.0? This is called the era of manual labor. So what happened in this foundational phase? The agriculture basically relied heavily on traditional knowledge and practices, dependent on the human and animal power. Farmer basically used simple tools like hoes and plows, and with operation and farming is basically subsistence in nature. That is, they used to grow food only for their consumption purpose. The farming was more vulnerable to and more guided by natural calamities like drought and floods. And this era laid the groundwork for farming as we know it, fostering strong connections between people, land, and the local ecosystems. However, as population grew, the need for more efficient and productive farming methods became apparent, and it led to the next leap in agricultural evolution. The next is agriculture 2.0, and this is called the era of mechanization and chemical advancement during the year 1950. The advent of the Industrial Revolution brought monumental changes to farming practices, helping in the era of mechanization and chemical advancement. This period is also referred as Green Revolution, as it led to massive increase in crop yield and agricultural productivity. The main key features of this era, that is agriculture 2.0, was mechanizations, that is the introduction of machinery like tractors, harvester, and other equipment, which actually replaced the manual labor and drastically reduced the time and effort which is required for farming operations. The other integration is chemical fertilizers and agrochemicals, that is the development and wider spread use of chemical fertilizers and pesticides, which enhance soil fertility and also protected crops from various disease and pest. However, this innovation, that is inclusion of these chemical fertilizers and agrochemicals, came with certain significant environmental concern, that is such as soil degradation, water pollution, and loss of biodiversity. So the next is the breeding program. In this case, various public university, research institute and private companies, they started certain breeding program so that they could develop certain variety, new high-yielding varieties, and which are resistant to disease, pest, and other climatic conditions, which also increase the productivity of the crops. So these are certain inclusion in the era of agriculture 2.0. This era marked a shift towards intensive farming systems, and this could be referred as the foundations for modern agriculture. But it also introduced long-term challenges which is related to sustainability, as it is concerned with certain environmental concern. So next is agriculture 3.0, and this era is known as the precision agriculture, the era of precision agriculture, and it was during the year 1990s. The 1990s witnessed the advent of precision agriculture, in which condition the technological tools began to play a pivotal role in optimizing farming practices. Some key features of this agriculture 3.0 is integration of technology. Various tools like GPS, remote sensing, and GIS, that is Geographic Information Systems, which actually enabled farmers to collect data on soil condition, health of the crop, and also weather pattern. And this data-driven approach allowed for site-specific management, where inputs like water, fertilizers, and pesticides were applied only where it is required. Then this era also concerned with certain environmental awareness, as the era 2.0 created certain environmental concern. So as we have already mentioned above, the widespread use of chemicals during the agriculture 2.0 had raised environmental concern, and in agriculture 3.0 efforts were made to minimize waste as well as to reduce the ecological impact of the farming. And next is the increased efficiency. Precision agriculture techniques not only boosted productivity but also conserved resources, making farming more efficient and more sustainable. Therefore, agriculture 3.0 represented a significant leap forward, using a data to guide smarter decisions and also creating the groundwork for the digital revolution that followed. So after agriculture 3.0 we have entered agriculture 4.0, that is the digital revolution in the today's era, in recent era. So we are now in the midst of agriculture 4.0, where in the agriculture 4.0 the fusion of advanced digital technology is transforming farming practices, and this include automation and robotics, IoT, Internet of Things, and smart farming, AI, artificial intelligence, and big data analytics, which are some of the innovation of agriculture 4.0. And we'll discuss in details about this agriculture 4.0 and certain emerging technologies in the next session. So now come to why is incorporation of technology needed in agriculture as well as in economic development. As we all know that agriculture is the mainstream of human civilizations for over 12,000 years, and it has transformed societies by ensuring stable food supplies as well as it promoted economic growth. And in the recent years, it feeds around 7.7 billion people. However, it faces many challenges, and these challenges like in environmental degradations, overexploitation of resources, and food insecurity. As far as the environment is concerned, the agricultural sectors contributes 23% of global greenhouse gases, which is primarily responsible for the recent increase in temperature. It also consumes 92% of freshwater resources, and it wastes nearly 40% of its produce. This is according to a report by Food and Agricultural Organization 2007. So these challenges are also compounded by certain other challenges like rising population as well as change in climate, and which ultimately created a threat to global food security. As per a report by World Health Organization's 2023, over 345 million people currently food insecure. So, to address these issues, and increasing agricultural productivity is critical, and it is especially in developing regions, which is characterized by more number of smallholders from farmers. So we can cite the example of India. With all these challenges, this is somewhat difficult to increase the agricultural production to feed the growing population. However, modern agricultural technologies like high-yielding seed variety, precision farming, IoT, and climate smart practices can enhance yield, reduce cost, and also improve resilience to climate change. Additionally, innovations such as coal, plasma, and ozone technology, which are transforming in the area of food processing and storage, and it also reduces the post-harvest losses. As far as the post-harvest losses is concerned, as we know that in developing countries, not only in the developing countries, but in the countries in actually globally, food get lost or waste due to improper post-harvest management and practices. An estimated of around 1.3 billion tons of food, that is 14% of all produced, is wasted globally every year. But in the same time, if we look into certain region like sub-Saharan Africa, despite significant potential, they need to struggle with the adoption of advanced agricultural techniques because of certain issues like lack of economic support, infrastructural support, as well as the knowledge barrier. So unlocking this potential could add 100 million tons of annual food production, as well as it can improve the livelihood of millions of people. So therefore, engaging youth and smallholders in innovation and integrating policy that support sustainable farming practices are crucial steps forward. For example, studies in Ethiopia and Tanzania show that adopting improved farming technologies reduced poverty and increased household welfare. Dear learners, it is reported that by 2050, the world populations will be around 9 to 10 billions. So with an additional 2 billion people to feed by 2050, the agricultural sector must evolve to increase productivity while at the same time minimizing its environmental footprint. Therefore, solution that includes adoption of technology, I have already mentioned, like precision farming, IoT, to enhance efficiency and sustainability. and it engages young people and smallholders farmer to drive innovation and growth. Now let's have a discussion. Technology in agriculture in Indian scenario. As far as the agriculture in India is concerned, we need to look into some problems of Indian agriculture. So first is the problem of land. So what is this? That is land fragmentation. In India, average land holding size reduced to around 1.08 hectares as for 2015-16 data, which actually limited the economic of scale. Then the next is soil degradations, erosion, nutrient depletion and salinizations due to overused, overgrazing, deforestation and use of chemical fertilizer, which cause this kind of soil degradation. Then the next problem is associated with water scarcity. Now the per capita availability is 1500 cubic meter per year, and it is estimated to decline by 25% by the year 2050. Then the irrigation gap, that is only 40% of cultivated land is irrigated and over 60% of groundwater is overexploited, because only 40% of cultivated area is irrigated and other 40% need to depend on groundwater, and thus groundwater is overexploited and thus decreasing the level of groundwater. Third one is the energy, that is high cost and limited access to electricity hinder modern technologies like drip irrigation as well as cold storage. And the next one is labor, that is unavailability and lack of skilled labor, shortage of skilled labor, and this is due to urban migration as well as the low wage rate, especially during the peak seasons. So these are certain issues that is associated with Indian agricultural systems. Therefore, in this scenario, technological innovation plays a pivotal role to overcome this problem as well as in advancement of agricultural productivity. There are four main factors for the technology in agriculture. So what are these main factors? First one is genetics. That is, genetics means certain breeding programs, that is to develop certain high yielding varieties, high yielding dwarf varieties, like say for example in case of wheat and rice during the green revolutions, which actually boosted nutrient absorption as well as crop yields. Then the second is crop nutrition, that is inclusion of fertilizer with more NPK content. NPK means nitrogen, potash and phosphorus, which also increase the crop yields. Then the third is the crop protection. Crop protection means crop pesticides, herbicides and insecticide, which minimize the losses from various pathogens, disease, insects, weeds and maximize the genetic potential. Then the next is farm mechanization and agronomic practices. This includes tractors, drip irrigation, laser land levelers and intercropping, which improve the productivity as well as resource use. Therefore, it can be seen that inclusion of technology in agriculture can help in following ways. First one is food security, then second land fragmentation solution, then third is higher production, then water management, then energy efficiency, labor productivity and ultimately the sustainability. Now let's have a look in the achievement in the agricultural growth in Indian scenario. India's first Prime Minister, Pandit Jawaharlal Nehru, once said that everything else can wait, but not agriculture. While Mahatma Gandhi observed, there are people in the world so hungry that God cannot appear to feed them except in the form of bread. So this statement highlight the vital role of agriculture, especially in post-independence. And in post-independence, this sector received priority, and thus the journey started with the campaign Grow More Food campaign in the year 1947. With technological integration, scientific advancement, meticulous planning, as well as relentless effort of millions of farmers. As we have discussed that we have many challenges like unpredictable weather, declining soil health, rising temperatures, and emergence of more resilient pests and pathogens. However, science and technology, that is inclusion of science and technology in agriculture, that is science and technology led agricultural development, transform India from a food deficit nation into one that is food sufficient, and then food surplus, and even a food exporting country. As you can see in the figure that between 1950 to 51 and 2021-22, India's food grain production rose dramatically from 51 million tons to over 314 million tons. Similarly, the production of horticultural crops grew 11-fold, fish production increased 18 times, milk production surged 10 times, and egg production expanded by 53 times. So these advancements have made a profound impact on the nation's food and nutritional security, and this advancement is possible with the inclusion of technology and innovations. So from the above discussion, it can be realized as technology in agriculture is no longer an option, but it is a necessity. It addresses the urgent challenges of food security, environmental sustainability, as well as resource efficiency, while driving economic growth by enhancing productivity, promoting rural development, and boosting the competitiveness. Government, private sectors, and farmers must work collaboratively to ensure widespread adoption and equitable access to agricultural technology. So, dear learners, before we conclude, let us pause for some small questions. So, first one is, what is a key features of agriculture 2.0? Number 1, use of IoT and smart farming. Number 2, mechanization and chemical advancement. Number 3, automation and robotics. Number 4, use of precision farming techniques. Then the second question is, the term precision agriculture is associated with which phase of agricultural evolution? Number 1, agriculture 1.0. Number 2, agriculture 2.0. Number 3, agriculture 3.0. And the next is agriculture 4.0. The next question is, agriculture 4.0 is primarily characterized by the use of which of the following technologies? One is chemical fertilizers and pesticides. Second is GPS and GIS systems. Third is automation, IoT, AI and big data analytics. Then the fourth is manual labor and traditional knowledge. Then the next question is, Which of the following is a challenge faced by Indian agriculture? The first one is excessive availability of skilled labor. Then the next is fragmentation of land holding. The third one is surplus water availability. And the fourth is declining population dependent on farming. So with this we conclude today's session. Stay engaged and curious. In the next sessions, we'll discuss about green revolution as well as certain emerging technologies in agriculture. Thank you.